Could consciousness be a subset of the universal quantum electromagnetic field? What is the nature of reality as described by modern physics? How can these topics be related to ancient Vedic texts? Find out in today's video. Scientists are engaged in the formidable task of reconciling gravity with quantum mechanics, a profound conceptual challenge. Leading contenders in this quest are string theory and loop quantum gravity, both proposing that matter and space-time emerge from the vibrational dynamics of strings or interwoven loops at the quantum level. These theories posit that our classical reality is an outcome of these quantum building blocks. Twistor theory offers an alternative perspective, presenting a geometric framework that reimagines the structure of space-time to elucidate natural laws. The uncertainty surrounding which theory, if any, is correct adds to the intrigue of this scientific pursuit. Physicist Jonathan Oppenheim from University College London introduces a post-quantum theory of classical gravity to bridge the gap between quantum theory and classical gravity. This theory suggests a probabilistic evolution of states, likening it to a game of chance. Oppenheim challenges the prevailing assumption that space-time must adhere to quantum principles due to the quantum nature of matter. He asserts that treating space-time classically leads to random fluctuations in gravity. In Oppenheim's post-quantum theory, particles remain excitations of quantum fields within the framework of quantum field theory. Here, space-time is described as a backdrop in which quantum fields, such as the electromagnetic field, exist and evolve. In this context, space-time serves as a stage for the evolution of quantum fields and their associated particles. The collapse of the wave function arises from the interaction of these field excitations with classical space-time, challenging the notion that gravity must strictly conform to quantum principles. The introduced randomness implies that the gravitational field may not always determine the particle's trajectory, introducing unpredictability and addressing the paradoxes observed in experiments like the double-slit experiment. Oppenheim's proposal suggests that for a consistent classical theory of gravity within a quantized framework, gravity must have a fundamentally random nature. Quantum field theory describes fundamental forces and particles as excitations of continuous fields pervasive throughout space. These fields are not discrete particles, but rather fluid-like substances. For instance, the electromagnetic field is associated with photons, the quanta of this field. In this framework, particles are considered excited states of their underlying quantum fields, providing a basis for constructing physical models of subatomic particles and their interactions. In the realm of quantum field theory, all electromagnetic fields are ultimately described by the universal quantum electromagnetic field. The electromagnetic field, encompassing phenomena like light and other electromagnetic waves, is a fundamental force of nature with a quantum counterpart. From the perspective of quantum field theory, all electromagnetic fields, including those associated with light, are manifestations of the universal quantum electromagnetic field. Theories proposing an electromagnetic basis for consciousness suggest that the brain's electromagnetic field, generated by neuronal activity, is the locus of consciousness. According to these theories, conscious experiences are correlated with the brain's dynamic electromagnetic field. Quantum approaches to consciousness, including those involving photons, posit that quantum processes may play a role in understanding consciousness. The orchestrated objective reduction, OR, theory suggests that elementary acts of consciousness are neurophysiologically realized as gravitation-induced reductions of coherent quantum states. The conscious electromagnetic information, CME, field theory, proposed by John Joe McFadden, posits that the brain's electromagnetic field integrates digital information from neurons to form a conscious electromagnetic information, semi-field. This field is considered causally active and encodes information related to conscious experiences. If electromagnetic theories of consciousness are correct, such as Orsh, Or, or Simi, one could hypothesize that the brain's electromagnetic field, consciousness, is a subset of the universal quantum electromagnetic field. The field theories of global consciousness, rooted in the Vedic tradition, propose the existence of an all-encompassing field of pure consciousness known as Atman or Brahman. This universal field of consciousness is considered the soul and whole cause of all physical. In Vedic thought, it is known as Brahman, the absolute, and constitutes the supreme reality, the origin and the end of all. John Hagelin, a theoretical physicist and proponent of transcendental meditation, TM, has proposed a modern unified field theory of consciousness. An article penned by Hagelin titled, "Is Consciousness the Unified Field?" A field theorist's perspective explores the connection between consciousness and the unified field from the standpoint of field theory. Hagelin, influenced by the Vedic tradition and the practice of transcendental meditation, proposes a unified field theory of consciousness. This theory suggests that consciousness is a unitary field underlying the diversity of the material world. Hagelin draws on Vedic philosophy, emphasizing the distinction between the brain, mind, and consciousness, asserting that the physical brain is an instrument for the mind, and the mind is an instrument for a deeper consciousness. These theories offer a unique perspective on consciousness, integrating ancient philosophical concepts with modern scientific understanding.